Can we ever dream of a world where natural disasters no longer wreak havoc on our lives? This is a question that has intrigued mankind for centuries. From the onset of civilization, humans have been at the mercy of Mother Nature's whims. Hurricanes, cyclones, and other natural disasters have left a devastating trail of destruction, claiming countless lives and causing untold damage. The human spirit, however, is indomitable. We've always strived to overcome adversity, to tame the wild and unpredictable. In our quest to minimize the impact of natural disasters, we've turned to science and technology, and one potential solution that has emerged is weather manipulation technology. Think about it. What if we could control the weather, redirect hurricanes, and weaken cyclones before they hit land? It sounds like something out of a science fiction novel, but this dream could one day be reality, thanks to the groundbreaking work of scientists around the world. At the heart of this idea is the McGinty Equation. This mathematical formula, which combines the principles of quantum field theory and fractal mechanics, could potentially give us the tools to manipulate weather patterns. The equation, in its simplest form, is represented as P's xt equals sign Psqft xt plus P's fractal xt dmqs, where Psqft xt is the solution of the free quantum field theory and P's fractal xt dmqs represents the fractal potential term with a self-similar fractal structure. The equation's modified version incorporates the effects of gravity on the quantum field, adding another layer of complexity and potential. With the McGinty equation, we could theoretically predict and alter the course of hurricanes, reducing their impact on vulnerable regions and saving lives. But, as with any powerful tool, there are ethical and practical considerations. Weather manipulation technology could be a double-edged sword, with potential for misuse and unforeseen consequences. So, it's essential to approach this frontier of science with caution and respect for the power of nature. Imagine the possibilities if we could harness the power of the McGinty equation to control the weather. A world where natural disasters are no longer a necessary evil, but a controllable phenomenon. That's a future worth striving for. A mathematical equation may seem daunting at first glance, but let's unravel the McGinty equation together. The McGinty equation, or MECO, is a mathematical formula that could potentially pave the way for weather manipulation technology. The equation reads as P's xt equals sign P's qft alasha x plus P's fractal xt dmqs. Now let's break this down term by term. P's xt is the total wave function. It represents the state of a quantum system at a certain point in space x and time e. This is the result we're interested in, the final prediction of the system's behavior. SQFT TXT, the first term on the right, is the solution of the free quantum field theory. Quantum field theory, or QFT, is a framework that combines quantum mechanics and special relativity to explain the behavior of particles. In the context of weather manipulation, this could relate to the tiny particles that make up our atmosphere. Next comes Psfractal XTDMQS, the second term on the right. This term introduces the concept of fractals, which are patterns that repeat at every scale. These fractals could represent the self-similar nature of weather patterns, like the spiral arms of a hurricane or the branching of lightning. The variables D, M, Q, and S within this term represent different parameters, such as the fractal dimension or the strength of the quantum field. Each of these parameters could have a unique effect on the weather system we're trying to manipulate. But remember, this equation doesn't exist in isolation. It can be modified to include the effects of gravity, as in the modified McGinty equation, or even combined with general relativity. These modifications could help us account for the massive forces at play in our planet's weather systems. So, while it may initially seem complex, each part of the McGinty equation tells a story about the nature of our universe and potentially our ability to influence it. The McGinty equation isn't just numbers and symbols, it's a potential key to unlock our control over the weather. Now that we understand the McGinty equation, let's delve into its modifications. We've learned how the McGinty equation uses solutions from the free quantum field theory and mechanical systems to predict weather patterns. But what if we could make this equation even more powerful? Enter the modified McGinty equation. Here we introduce a new term, gravity STG. This term represents the perturbative effects of gravity on the quantum field. And G? That's a parameter that characterizes the strength of the gravitational force. But why add gravity into the mix? Well, in the grand scheme of things, gravity plays a significant role in weather phenomena. The gravitational force exerted by the Earth has an impact on the atmosphere's movements, influencing the formation and propagation of weather systems. By including gravity in our equation, we're adding another layer of precision to our weather predictions. Then there's the fractal potential term VYT. This term has a self-similar fractal structure described by the constant parameters V0, L, and S. This fractal correction term brings an element of self-similarity and scale invariance into the equation, reflecting the intricate repeating patterns found in nature, including weather systems. Deriving this term isn't a walk in the park, though. It involves a combination of integral calculus, Laplace transform, and the convolution theorem, but the payoff is worth it. This fractal correction term enhances the equation's ability to mimic and predict the complex fractal nature of weather patterns, making our equation even more robust. So what does all this mean? In essence, the modified McGinty equation isn't just a minor tweak. It's a significant enhancement that increases the equation's potency and precision. It equips us with a more sophisticated tool to predict and potentially manipulate weather systems. Modifications to the McGinty equation aren't just amendments, they're enhancements, increasing our chances of controlling the weather. We've journeyed through the complexities and simplicities of the McGinty equation and its modifications, but what does it all mean? In layman's terms, it's a promising step towards a future where we have the power to control and redirect natural disasters like hurricanes and cyclones. The McGinty equation, with its fractal potential term and gravitational parameters, allows us to delve into the heart of these weather phenomena and potentially manipulate them. By adding the modifications to the equation, we're incorporating the effects of gravity on the quantum field, which can have a significant impact on the behavior of these weather systems. It's like having a new set of tools to work with, tools that might just help us reduce the devastating impact of these disasters on vulnerable regions, saving countless lives. As we continue to unravel the mysteries of the McGinty equation, we might just be on the brink of a revolution in controlling natural disasters.